about to talk to you about kinetic energy. The kinetic energy of an object is the energy which it possesses due to its motion. It is defined as the work needed to accelerate a body of mass, given mass, from rest to its stated velocity. Having gained this energy during its acceleration, the body maintains this kinetic energy unless its speed changes. The same amount of work is done by the body in decelerating from its current speed to its state at rest. In a good example, it would be a roller coaster. Going up would be building the energy, and then going right back down would be speeding up, and then right towards the end of the ride, that's when it would end. The speed, and thus the kinetic energy of a single object, is frame-dependent, relative. It can take any non-negative value by choosing the suitable inertial frame of reference. For example, a bullet passing an observer has kinetic energy and reference frame of this observer, but the same bullet is stationary, and so has zero kinetic energy from the point of view of an observer moving at the same velocity as the bullet. By contrast, the total kinetic energy of a system of objects cannot be reduced by zero by a suitable choice of the inertial reference frame unless all objects have the same velocity. In any other case, the total kinetic energy has non-zero minimum and has no inertial reference frame can be chosen in which all the objects are stationary. And minimal kinetic energy contributes This minimum kinetic energy contributes to the system's invariant mass, which is independent of the reference frame. The difference between this and the gravitational potential energy is that gravitational energy is the potential energy associated with the gravitational force. If an object falls from one point to another point inside a gravitational field, the force of gravity will do the positive work of the object, and the gravitational potential energy will decrease by the same amount. With kinetic energy, it may be best understood by examples that demonstrate how it is transformed to and from forms of energy. For example, a cyclist uses chemical energy provided by food to accelerate to a bicycle to a chosen speed. On a level surface, this speed can be maintained without further work, except to overcome air resistance and friction. The chemical energy that has converted into kinetic energy, the energy of motion, but the process is not completely efficient and produces heat within the cyclist. So basically, that's the difference between kinetic energy and gravitational potential energy.